So let's work through a complete problem now. And we learned some steps along the way, some tools that will help us to go to solve the actual problems that we want to start to explore. I want to solve this quadratic equation, x squared minus 6x plus 4. And I want to do it through this method of completing the square. So there's going to be a couple of things that will be kind of new to us as I do that. Not new that we haven't explored those tools, but new to you and how I'm going to employ those tools in this problem. So I want you to pay close attention to that so we can start to see where this goes. Well, my strategy completing the square is I want to craft a perfect square trinomial. And that's the starting spot that I want to go. So to do that, I'm going to subtract this constant and put it over on the other side, basically just to clear it out of the way. So now I can start with a partial trinomial and just imagine what's the best number, or in fact the only number, that will turn this into a perfect square trinomial. You might be asking why. Just watch. Hang on, we'll find out why in a second. It's really cool what's going to happen. But for now, let's go back and remember, how do we complete the square? So we take this middle term, divide it by 2, and then square that middle term. So I know that 9 is the magic number that turns this trinomial into a perfect square trinomial. However, remember back in our early algebra days, we just can't add a number into the equation. We have to do something to maintain its balance. So if I add a 9 to this side of the equation, I better add a 9 to the other side as well. That's correct. So now my equation stays balanced. So from here, the reason why we're looking for this 9 is because we know it factors down into x minus 3 squared. And over on the other side, I have a positive 5. Reason why that's useful, the reason why we wanted to go through this entire process is because I wanted to get to something that I hope we remember looks familiar. Doesn't it look like that square root property? Doesn't it look like some u squared equals our d? That was our goal. We wanted to get to that point and now use that earlier tool that we learned how to use. That means I can take the square root of both sides. And that's helping me solve for x, which is the goal of all of our equations, is to solve for those unknowns that make our equation true. So I can take the square root of both sides, square root of both sides, square root of both sides. When I do that, I have to make sure I'm looking at both the plus and its negative solutions. And from here, to isolate x by itself, I can add 3 to both sides. So x equals 3 plus or minus root 5. And there are my 2 solutions to this initial equation, my initial quadratic. I don't think, if we were just left with our factoring strategies, I don't think I would have been able to factor this down into those 2 responses right there. I don't think I would have been able to come with x minus that, 3 plus or minus, one's the plus, root 5, and the other one's 3 minus the root 5. I don't think I would be able to factor those and guess those particular factors to make that particular equation true. So we're looking at another strategy, and the strategy is through this idea of how do we create a square, complete that square, then factor that square out.